Hi everyone, this lesson will cover how to evaluate logs. Okay, so let me recall along with you that 2 to the first power is 2, 2 to the second is 4, 2 to the third is 8, and 2 to the fourth is 16, and we can continue, but we have done this in class. You will see it again today when we evaluate logs. Also, the square root of 2 is the same as 2 to the half power, and the cube root of 2 is the same as 2 to the third power, and we can continue this with different values. Or different roots, okay? So this is the plan to evaluate logs. We're going to use the heart method, which I went over on the previous lesson. That's the first step, and then the second step is you want to make the bases the same. And then the third step is you equate the exponents once the bases are the same. So with that said, let's go into the first example. So I'm going to evaluate the log. So what we're going to do is following the heart method, raise the base of this log to the power of x and set that equal to the number 36. Okay, so then this is 6 to the power of x is equal to 36. So the next thing we need to do is, since we have a base of 6 on this side, we need to get a base of 6 on this side. So then I'm going to write this as 6 to the power of x, and we know that 6 goes into 36 6 times, so that 6 times, which means 36 is the same as 6 squared. So as you can see, we have the same base. So this is step 2. So then what we can do next is we set the exponents equal to each other, or equate the exponents. So this just means that x is equal to 2, and we're done. So this is kind of solving exponential or logarithmic equations, but not really. Okay, so this is kind of the introduction to it. So the second example. This is the base, raise it to the power of x and set it equal to 8. So then this is 2 to the x power is equal to 8. Now remember I said you're going to need this because 2 to the third is the same as 8. So we got to have the same base, which is 2. So then this stays the same. But the 8, we can change that to 2 to the third. And now, since we have the same base on both sides of the equation, just set the exponents equal to each other. So then x equals 3. Okay. Next example, if you don't have anything on this side, then you can just write the x. So then we raise the base, which is 3 to the x power, and that equals 3. So then we say the following, 3 to the x is equal to 3. But notice that we have the same base, but also this means that 3, it's implied to be 3 to the first. So 3 to the x is equal to 3 to the first power, which means the x value is 1. Okay, the value of x is 1. Right, next example. On the next example, again, let's set this equal to x, which is the unknown. Okay, we're to evaluate the log. So then raise again 3 to the power of x and set it equal to 1. So this is 3 to the x power equals 1. Then, I don't know if you guys remember this, but for this one here, the only way this is possible, okay, any number or value, a variable or number equal to, to a 0 power is 1. So the only way this is possible is if we have this, which means 3x equals 3 to the 0 power, which is 1. So then that means the value of x in this case is 0, and that's the answer to that example. Okay, so this is going to come in handy since we've seen it before. This one again, set this equal to x, so we raise 9 to the power of x and set it equal to 3. So we have 9 to the x power equals 3. We need a base 3 on this side, so that means this becomes 3 to the 2x power equals 3 to the first power. So now we have the same base, which means I'm going to come over here for the sake of space. So then say 2x equals 1, setting the powers equal to each other since we have the same base. Then we divide by 2. So then the value of x is 1/2. Okay, and that should make sense because the square root of 9 is equal to 3. Okay, next example. Set this equal to x, then raise the base to this power and set it equal to 5. So we have 125 to the power of x is equal to 5. So then we know that this is 5 to the first power. But 125 is 5 to the third power. Okay, so I'm going to write this in the following form. So 5 to the power of 3x is equal to 5 to the first power. Okay, So then since we have the same base, then let's set the exponents equal to each other, which means that 3x equals 1, then divide by 3. So then we find that x is equal to 1/3. So, and this should also make sense because this is the cube root of 125, which is equal to 5. So let's move on to the next example. Okay, so for number 7, set this equal to x. So then 16 to the power of x is equal to 8. So that's what I'm going to write here. And then I'm going to find the same base, and the closest one I can find is 2, because we know that 2 to the third is 8. So then this we can do as 2 to the third power. And this one is 2 to the fourth, because, I'm sorry. My mistake. Yes, I'm correct. So 2 to the fourth is 16, right? So this will be 2 to the power of 4x. So then we have the same base. Then we set the exponents equal to each other. So 4x equals 3. Then divide by 4. So then we find that x is equal to 3/4. And I apologize about that. Okay, next example. Set this equal to x. Then raise the base of the log to the power of x, set it equal to 1/7. So then this is what we have. 7 to the power of x is equal to 1/7. Now don't forget that if this 7 is in the denominator, that means it's got a -1 as a power. So then I'm going to use that fact. So 7x equals 7 to the negative first power. So then since we have the same base on both sides of the equation, then we know that x is equal to -1, and that's the only way this is possible. All right, next example. So for this one, let's set this equal to x again. Raise 1/3 to the power of x and set it equal to 27. So we have 1/3 to the x power, or to the power of x, is equal to 27. Okay. And again, don't forget, the only reason why this is 3, this 3 is in the denominator is because this power has to be negative, right? So let's make that statement here. So we have 3 to the negative first power, 1x power, negative 1x power equals, and then let's change this 27 to a 3. 27 is the same as 3 cubed. So then we have the same base, which means that negative 1x is equal to 3. So then divide by -1. So then we find that x is equal to -3. And that is the answer to example number 9. Next example. Again, set this equal to x. Raise 16 to the x power and set it equal to 1/2. So this is what we have. 16 to the power of x equals 1/2. Again, if the 2 is down here, it's because it has a negative power. So I'm going to change this 16 to a 2. And again, I gave you that here. So 2 to the fourth is 16. So then this is going to be 2 to the fourth times 4x power is equal to 2 to the negative first power. So then we set 4x equals -1. And then we solve for x. So divide by 4, divide by 4. So then the answer to this problem is x equals -1/4. Okay, and that's all for number 10. Number 11. So I'm going to change this to a half power in a moment. So let's set this equal to x. So 1/2 to the power of x is equal to, I'm going to change this to 1/4. 1/4. So then this is 1/2 raised to the power of x is equal to 1/4. Again, this 1/4 is in the denominator. And if it's 1/4, that means it's got a negative power. But don't forget, this 4 can be also written as 2 to the second power. Okay, so I'm going to use that fact for this one. So I'm going to say that 2 times -1x as a power is equal to 2 to the negative second power. So then we have the same base. This is positive 2, by the way. So then we set the powers equal to each other. So -1x equals -2, then divide by -1. So then we find that the value of x is +2. And that is the answer to that example. Okay, let's go on to the last example in this column. This is implied to be base 10. So I'm going to write it for now. So this is the common log, and set this equal to x. So 10 to the power of x is equal to 100. So we have 10 to the x power equals 100. Again, the base of this is 10, so we need to make this 100 into a base 10. So then this is 10 to the second power. So 10 to the power of x equal to 10 to the second. We have the same base again. Just set the powers equal to each other. And we don't have to do anything else. That's all for this example. All right. 2 more examples like this. So notice this is the square root of 10. Okay, remember I said if you see the square root, that means it's the half power. So in this case, it's going to be the half power of 10. So let's set this equal to x. Again, this is implied to be base 10. That's the common log. So raise 10 to the power of x, and that equals this. So then I'm going to write it down. 10 to the power of x is equal to the square root of 10. But then I'm going to use the fact that the square root is the same as a half power. So then this means that 10 to the x is equal to 10 to the half power. Since we have the same base, again, we just set the exponents equal to each other, which means x equals 1/2. Okay, and we're done with that one. So for this one here, this is the cube root, right? Remember I mentioned this? This is a 2, but it applies to any number. So then this is base 10, and let's set that equal to x. So then 10 to the power of x is equal to the cube root of 10. So I'm going to write that down here. So let's see, 10 to the x power equals the cube root of 10. Again, we have the same base, and we know that the cube root is the same as the third power, right? So then this means that 10 to the power of x is equal to 10 to the 1/3 power. So we have the same base, which is base 10. So then the exponents, we set them equal to each other. So x equals 1/3, and we are done with this one. For the next part, remember that pi is approximately 3.14, but not exactly. We're rounding here. And also the number e, which you got introduced into this number on the previous lesson, okay, is equal to or approximately 2.72. Also, we do not use this, we don't write it this way like log base 10 of 7. We cross this out, you'll see it this way. Okay, so this is the common log. And this one here is the natural log, so we won't see it this way. This is how you'll see it. So just want you to remember this because I mentioned this in class yesterday, and I hope that makes it easier today. So for this one here, this is the same as log base e, right? So in this case, we don't have a 7, we have the number e. So when you take the inverse of this one, I mean not the inverse, let's say this is equal to x, right? So let's set this equal to x. Then the base of this log is the number e. So then we take e to the power of x is equal to e. So e to the x power is equal to e. But again, if you don't see a number with this number e, then that implies that the power is 1. So then e to the power of x is equal to e to the first power, which means we have the same base. So then we just set x equal to 1, and we are done with this problem. Okay, next example. Same idea, but notice now this e has a third power. So then the base of this log is e because it's a natural log. So then we set this equal to x. So we say e to the x power. Again, coming from this, okay, which I said here, the base of the log is e. So this is equal to e to the third power. So then since we have base e on both sides of the equation, set the powers equal to each other, and we are done with this one. One last example. So for this one here, this number e is inside of a square root. Okay, so don't forget square root is a half power. So let's set this equal to x, which means the base of the natural log is e. So then e to the power of x is equal to the square root of e. But then again, the square root is the same as a half power. So then rewrite that as e to the x power equals e to the half power. So then we have the same base again. So then x is equal to 1/2. And this is all for this lesson. I'll see you guys in class. Bye-bye.